All right, good morning, and welcome to our Smarter, Safer Hot Water webinar. I'm your host, Greg Jackman, the Specification Program Specialist here at Watts. Today's webinar is the next installment in our series of webinars geared specifically for you guys, our engineer, architect, and specifier customers. Just to give you a little bit of background on the series, we hold several webinars throughout the year that cover a variety of topics. Our presenters are our in-house technology and product experts, and thanks to our partnership with the American Society of Plumbing Engineers, ASPE, we're able to provide you with 0.1 Continuing Education Unit, CU, credit if you stick around for the entire webinar. After today, our next one will be on September 26th, where we'll be talking about the ultra-hygienic drainage solutions. If you're interested in registering, you'll see a link to the registration page when this webinar ends, or you can reach out to me directly at gregory.jackman@wattswire.com, and I'll sign you up. The link will also be in our emails as well, so keep an eye out for those. With that being said, I'd like to introduce you to the presenter of today's webinar, Bruce Fathers, our Senior Product Manager of Heating Solutions at Watts. Bruce has been active in mixing valves for over 25 years, holding positions in product management and marketing. Bruce has authored numerous articles on hot water safety for commercial applications and received his MBA from DePaul University in Chicago. During the duration of Bruce's presentation today, the phone lines will be muted, but we encourage you to submit questions via the chat window. Just hover over the chat icon at the bottom of the WebEx and type in your question there. We'll then address them after and during the presentation. So with that, let me pass off to Bruce to get started.
Okay, thank you, Greg. If there was any confusion in the picture, I was the one to the very right. That was my family on a recent trip to Hawaii. But anyways, let's move on. So in terms of the course summary, again, I'm glad that there's so many people that are attending today, and we're going to specifically talk about specifying and using digital mixing and recirculation stations in tempered water systems. And we're going to primarily focus on energy conservation, including also water conservation, and then we want to talk specifically about some of the risks that are involved in how digital mixing helps mitigate those risks in terms of excessive hot water temperatures and the occurrence of Legionella. So after completing this presentation, this is what we hope to accomplish, that you'll be able to identify challenges and dangers inherent in hot water delivery systems in commercial buildings. We want to make sure you have a better understanding of the full system, including point of distribution or point of source valves, all the way through to point of use valves at the lavatories and showers and other fixtures and fittings. We want to talk and discuss the advantages, again, of digital mixing around protection, performance, and risk mitigation. And then we're going to talk a little bit about components of digital mixing systems and stations, and also more specifically around the standards that apply to them. And then finally, again, we want to discuss again, the integrated hot water delivery system. It's important to look at this as an entire system and not just look at individual valves or fixtures. So again, here's a quick outline. We're going to do a brief introduction, then we're going to talk about some mixing valve basics and smart system design components. Again, we're going to get more into performance enhancements over traditional mixing valves, and we're going to talk about the standards, the safety standards that are involved. And then we're just going to talk a little bit more specifically around electronics and applications and project types. So again, as we kind of outlined earlier, there's obviously been a rise in the number of people scalded in public buildings, and particularly what we're seeing now are increased cases of Legionnaire's disease outbreaks. And these are things that obviously are very important, and these are risks that are inherent to domestic hot water systems. So again, maintaining and controlling water temperature throughout the entire distribution system is critical, all the way from starting at the point of source and all the way to the point of use. as I think probably most are aware online, temperatures and burns become excessive at around 120 degrees. That's when burns can actually take place. And so, you know, most codes recommend that all the components in a hot water delivery system, the temperatures are set to prevent excessive hot water. And that typically at the point of use revolves around setting limit stops and making limit stop adjustments. And again, as I think many of us are aware, there can be wide fluctuations in water temperatures supplied to any plumbing fixture. So that can vary based on your incoming water pressures. It can vary on the demand in a building. There's a lot of things that can impact water temperature in a building. So protecting it throughout the entire system is critical. Recently, a study was done of major hotel chains, and just as kind of some real life information where over 100 hotels were sampled for their hot water temperature in guest rooms. And in 91% of the first 100 rooms that were tested, we found temperatures of 115 degrees Fahrenheit and greater. And in 78% of those rooms, we found temperatures of 120 degrees Fahrenheit and greater. And again, just to remind everyone, at 122, it takes about a minute to produce a first-degree burn, and at 140, minutes become seconds. So there's the risk of obviously scalding, and then there's the risk of thermal shock, right, which is a sudden change in water temperature. It could be hotter, it could be colder, that results in someone within a shower falling or stumbling, and that fall can cause a serious injury. So again, these are kind of real life examples, and the way these temperatures were taken was we'd go into a facility and we would measure the temperature at the shower and the faucet by turning the handle to the full hot position and record the maximum temperature. So as you can see, many facilities at the point of use are running very warm temperatures. Why don't we do the first poll question, Greg?
Sure.
And see if anyone has experienced this on their own.
Yeah, so the first poll question here is, has anyone experienced excessive hot water temperatures in a commercial facility recently? And you can see on the right of the WebEx the answer yes or no. Give it a few seconds
Yeah,
here.
give it a couple seconds, yeah.
All right, I think we're good.
Okay. So it looks like we've got about a quarter right now of the respondents responding yes. And again, this is what the valves turn to the full hot position, right? That's where the excessive, but actually in the hotel I'm staying at right now, the water temperature is very, very hot. So it is something that's common. Now, on the other side of the coin, in terms of Legionella, it's estimated that from the Center of Disease Control that 8,000 to 18,000 people are hospitalized with Legionnaire's disease each year. And again, you've got to remember too, in 62% of the hotel rooms that we had surveyed had hot water that was at 115 degrees or below. So the ideal temperature range for Legionella is between 95 and 115. Now, hot water Legionella can occur in hot water domestic systems. It can occur from cooling towers. It typically takes place when the bather or the user would inhale aerosol or mist containing the bacteria. So again, the ideal temperature growth range for Legionella is between 95 and 115. Water temperatures must be high enough at the point of source to prevent bacteria growth, but again, have to be managed at the point of use to prevent excessive water temperature or scalding. And you can see many people have seen this chart to the left, which kind of tells you there's the ideal range and also, you know, where, at what temperatures and how quickly bacteria is killed. When you get up to 158 degrees, that's the rapid kill rate, which is typical of kind of a sanitization or a hot water flush. That's typically where the temperature where those occur. And just to get back to kind of where Legionella originates from, I think it's common to hear people believe it's primarily from cooling towers, but at a recent healthcare summit that was attended, Dr. Janet Stout, who has her PhD and is director of special pathogens, the special pathogens lab, actually indicated that 56% of Legionnaire's cases come from the premise plumbing system, while 22% come from cooling towers. And interestingly enough, the mortality rate is actually quite high. It's 25 to 30%. It's something that's interesting. Most people think of Legionnaire's disease associated with healthcare systems. Actually, there are actually more cases in hotels than there are in healthcare. But in healthcare, that's where the higher mortality rate is. It's 85% of the deaths of Legionella actually happen in healthcare facilities, and that's primarily caused by compromised immune systems. So again, the challenge for professionals is minimizing scalding risk and at the same time minimizing the risk of Legionella and bacteria. And that's kind of tricky because when you raise hot water temperature, you're killing bacteria, but you're increasing the risk of scalding, and vice versa. When you lower water temperature, your risk of scalding goes down, but the risk of bacteria goes up. So this is a real challenge, and that's why you have to have kind of this complete systems approach to hot water. So if we kind of just take a step back and look at how we've been doing this, particularly at the point of source, the point of distribution, and we've been managing water temperature and still do effectively for quite a while, right? So if you look at the kind of thermostatic elements that are incorporated today in, let's say, in bigger mixing valves and smaller ones too, but there's bimetal, there's liquid filled, which might be like ether, and then there's more recently paraffin, which have been fairly common in smaller mixing valves, but over the recent years have kind of been pioneered into larger master mixing type products and high-low systems. So not a lot has really changed up until recently. So let's look at kind of this digital mixing and recirculation loop, and this is part of it. It's representative of your hot water source and a station, okay? So in this particular case, this is a digital mixing system, and you're managing essentially your mixed outlet temperature, and you're able to monitor and manage your return temperature as well. The hot water source, typically when you're using 2-temperature hot water is where digital mixing is ideal. Here. So, Greg, why don't we just do a quick poll, and be curious to know how many people are actually specifying or using digital mixing.
Sure. Let me throw up the next poll here. So you'll see up there now, approximately what percentage of your facilities tie hot water systems to BMS BAS? Give it 15 seconds or so for you to answer. All right, good.
Okay, so let's just take a look here. Still some answers coming in. So it looks like, is there a way to scroll up there a little bit? Yeah. Can they see the results?
No.
No. Okay. So just to let you know what.
Let me share the results right now. Hold on one second.
Okay.
Sorry about that. There we go. Should be able to see it now.
Okay, they can see it. So this is connecting through the building management system, obviously, is critical for system visibility. And when you look at digital mixing, and a clear advantage, obviously, over kind of traditional mixing valves is the ability to do this. And with many digital mixing valves and stations, the ability to connect to building management system is native to the controller or native to the unit, or in some cases there's a separate module that's required. But the bottom line is it does give you visibility into the performance of your system and what's being monitored at the various sensors throughout the system. So again, the new mixing stations can control the entire tempered water recirculation loop. And again, that ties into not only the ability to mix water, but also to control the pump. So in many cases, the controller acts as an aquastat, and as the temperature of your water cools off at the return, it can turn the pump on, and when it increases, it can shut the pump off. The basic requirements of a system like this, a point of source system, are dictated by the performance standards in ASSE 1017. And again, one of the clear advantages of digital versus traditional is its ability to control temperature to set point. So in the case of a mechanical mixing valve, the requirement through ASSE 1017 for a valve that flows greater than 40 gallons at, I believe, at a 10-pound drop is to control plus or minus 7 degrees. That's a 14-degree temperature band. With digital mixing, digital mixers are controlling to much tighter tolerances than that, plus or minus 2 degrees. So you essentially go from a 4-degree band to a 4-degree band, and that obviously has benefits in terms of the ability to control your hot water temperature. It ties into efficiency. It clearly ties into safety. So a very important benefit of digital mixing. Another benefit is the ability to monitor flow. Now, some systems can do this, some systems do not currently, but the ability to look at your mixed outlet flow and your return flow and then calculate load flow, and then on top of that, the ability to calculate the energy consumption around that is certainly a nice feature and benefit. The purpose of having flow meters, or I think one of the great benefits of having flow meters, is the ability to obviously see, is your mixing valve properly sized? In many cases, we'll see oversizing of valves, where the belief is, obviously nobody wants to run out of hot water. That's critical. So there's a tendency sometimes to go a little bit bigger. This is particularly true of mechanical mixing valves or thermostatic mixing valves. The larger you go, the more difficult it is to control it at lower flows, right? Digital mixing valves help mitigate some of that issue, but clearly you want your valve or your valve system to be sized properly. And there are programs that we'll talk about a little bit later that help you do that. But in most cases, what we find, and this was a fairly large hotel that had flow sensors on it, and this is like a 500-plus room hotel. And at peak hours, which were kind of early morning hours when you'd expect everybody up and showering, 500-room hotel, and it was about at 85% occupancy. The maximum flow into the building was just over 120 gallons per minute, much, much lower than was anticipated. So when this facility looks to do an addition or a renovation, this type of data will be very, very useful to them when they go to sizing their next the next valve. So digital water mixing and recirculations, again, provide more precise temperature control. We talked about that. And if you weren't aware, water heating accounts for about 8% of a commercial building's energy budget. Seen numbers fluctuate between some of the data between 6 and 10, but roughly about 8%. So it still is significant. And again, even small changes in temperature can, the ability to control temperature can mean, it can result in fairly large costs over time. So it's not to be underestimated. I'm going to skip that slide. So we're going to go right to a little bit more specifically about standard mixing valves, and then talk more about digital, a little bit more specific. So basically, thermostatic valve operation. There's a lot of text on this slide. I'm just going to, basically tell you, and I'm sure a lot of you are familiar. You're bringing cold water in one side, hot water in the other, and you're mixing it. And at the outlet, you're providing a safe mixed hot water temperature. And the heart of any thermostatic mixing valve, again, we talked about this earlier, is that thermostat. In this case, it's in the center of that diagram, and it's a paraffin-based element, which has got some wax mix, some copper, a diaphragm, and a piston. And based on the temperature of that water, it's moving the piston up and down and essentially increasing the hot while decreasing the flow, or vice versa, to maintain the set temperature. This is, again, talking a little bit about the temperature and the burn chart. So this gives you a little bit more specific information. This is, I believe, from Engineering and Science Division of the U.S. Consumer Product Safety Commission. So in this particular diagram, it actually, we talked before that temperature, burns can occur at 120. This one actually at 116. It takes a while, but you can actually incur a third-degree burn in 45 minutes. So, let's say 116 to 120. At 122, it's 1 minute and 5 minutes. And again, when you get into temperatures above 150 degrees, it becomes virtually instantaneous. So, and what mixing valves do is their goal is to prevent, these kind of temperature increases based on, various conditions. So there's a question that came in, what heat source is sufficient to use with digital mixing? Can standard water heaters be used, or will boilers have to be used? So listen, both. Typically we use digital mixing with, tanks, with instantaneous, with boilers. We've used them in numerous different applications with numerous different heat sources. Okay, another question. What if the power is out? How do you guarantee mixing? Do you need, do you need a backup UPS and a backup battery? So it works a little different with different mixing valves. If you lose power in the case of some, you go to full cold. So that protects against, it completely shuts off the hot water. And in that event, there's a manual override. So once you go to full cold, you can actually go down to the unit, and actually on the actuator, you can press a button and actually manually set the valve. if in case there's a power outage, and if you don't have, again, a battery backup system. So there are some, some safety nets in place to help you until the power returns. But obviously, we recommend whenever you can put it on a battery backup, that would be ideal. So again, the burn chart is pretty straightforward. I think we've all seen this, but it's very important to manage these temperatures, right? It's very important. And as we talked about earlier, the hotter water is great for killing bacteria, but again, the risks of scalding become more significant. And so that's why many guidelines recommend thermostatic valves at the point of use to ensure that you mitigate these risks. So at the point of source, hot water is set at a higher temperature and delivered to various point of use faucets, shower heads. We've already talked about that. A well-designed system will mix hot from the boiler or the hot water heater and cold water, and it's very similar, similar operation at the point of use. The temperature of the water is controlled through actually 3 different types of valves, depending on the application. If you're at a shower or a combination tub shower, it could be thermostatic, it could be pressure balancing, or it could be a combination valve. So ASSC 1016 allows for 3 very different type of valves to protect at the point of use for shower applications. So pressure balancing valve, which is also known as a type P, again, compensates for pressure fluctuations very well. It's not required to adjust or for temperature changes, but it is required, it does do pressure very well. And again, it's critical with any type of valve to make sure that the limit stops, are installed. And with pressure balancing valves in particular, because they can't sense temperature, it's very important to make sure that the limit stops are readjusted going from season to season. So, for example, if a valve is installed in the winter and the cold water is 40 degrees, and then by the time summer hits, maybe your cold water has risen to 60, 65 degrees, that's a 25-degree increase. Now, that full 25 degrees is not going to be translated to your outlet temperature, but it is going to increase the outlet temperature based on the same handle position. So again, it's important thing for the maintenance crew to be going room to room and making sure limit stops are readjusted. So mechanical mixing valves, this is focusing a little bit more on the master mixing type valves, the large thermostatic distribution valves. So these, again, we've talked about this earlier in the presentation. You've got liquid-filled, chemical-filled, bimetal, paraffin. There's lots of different approaches to this. But they provide very good performance, but under, obviously optimal conditions are critical. So having, relatively equal pressure is very important. Making sure that the installation is correct. Right, making sure that these are installed properly. From time to time every once in a while we'll see the hot and the cold pipe backwards, but that's kind of a rare case. But clearly, the installation and the system design is critical. Making sure that the valves are properly sized. We talked about that earlier. You don't want a valve that's too big because it'll struggle at lower flows to control. Having a recirc pump that's properly sized, make sure that checks are in the right places so you don't have cross flow. An implementation of a regular maintenance program is critical. These have to be looked at. And obviously, making sure that your water quality is very good. It's free of scale, debris, those type of things. So that's very, very critical for thermostatic mixing valves. It's important for digital as well, but very critical for traditional thermostatic mixing valves. Okay, so I'm going to talk a little bit more about digital versus thermostatic and some kind of the features that present themselves and the enhanced performance. Greg, why don't we do the next poll question here? Be curious to know.
Sure. So next poll question, have you specified or installed digital mixing valves in your current and past projects? Let me open that up. Did you see it there in the WebEx on the right? Yes or no? Give it another 10, 15 seconds.
Yep.
All right, let me share the results for you.
Okay, so it looks like twice as many, almost twice as many said they have specified or used digital mixing versus not. So it looks like we've got some, which is actually becoming more and more common. Digital mixing has really taken off the past few years. You have far more competitors in the marketplace, which is only good in terms of innovation, and obviously pricing it's going to impact pricing to some degree, but yeah, that's more competition is a good thing, and you can see that people are really taking to digital mixing because of a lot of the benefits that we've discussed and will continue to talk about. So again, one of the biggest benefits around digital mixing is this temperature stabilization of plus or minus 2 degrees. And this was in a previous slide, but it's worth mentioning again that performance of a 4-degree band to set point is much safer than 7 degrees, plus or minus 7 or 14 degrees. And again, that ties back to not only safety, also efficient use of your hot water. We talked about the digital water system being integrated into building automation. One big advantage of digital is the ability to kind of set up and commission. So in many cases, in most cases, it can all be done through an interface right at the station. It could be done over the building automation system, but it's very simple and easy to set up and to make adjustments. So this is kind of a typical system that you see here, and it looks like there's a lot of components there, but what you see here is a fully assembled, tested station. So this has already been properly sized. The pump has been selected by the engineer, or if we can, we or other manufacturers can select the pump based on, the requirements needed. But this system is custom designed. It's mounted on racks, and so it makes it very easy for the installer to put into the building and then to set up. So in terms of critical components, obviously the controller, which you can see in the upper left. There's sensors all throughout the system. So we're looking at mixed outlet temperature. We're looking at mixed outlet pressure. The system can also monitor the inlet hot and cold supply temperatures and pressures. There's a temperature and pressure sensor on the return. And then there's the pump, which is optional. Most units, if there's a pump that already exists, can tie into the unit, but their pump can be specified and built right into the unit if that's required. And if you look to the very right, they're kind of hard to see, but those are the flow sensors, which allow you the ability to kind of monitor your outlet flow, your return flow, again, calculate your load flow and then calculate your energy consumption the unit does all this for you in, in BTUs and therms and gigajoules, whatever you choose that can be selected. And then, so a couple things that aren't really pointed out, you've got obviously isolation valves throughout the unit, which makes it easy to get at components. There are check valves throughout the unit to make sure we keep, we mitigate the issues of cross flow. In this particular unit, you're simply modulating a three-way ball valve. So it's a very simple style valve, which makes it very easy for repair. You can see the actuator on the left-hand side, the silver device on the left-hand side, and that has, again, the manual override we talked about earlier. So in a lot of cases, the actuator is separate from the valve and makes, again, access very easy, maintenance very easy, so it's actually quite, it's kind of, again, we talk about plug and play, and that's the type of system that essentially we kind of look at this. The contractor, the installer, makes basically 5 water connections, brings 110 power to the unit, and the commissioning is very, very quick. The system essentially auto balances, right? All they're playing around with circuit setters and ball valves and balancing during low demand or zero demand conditions, it goes away. So you talk to a lot of contractors, they really like this unit because these types of units, because they make installation and commissioning very, very easy. So there's a question that says, what pressure drop would be expected on average with this type of arrangement? I would say what we see most people working with engineers specifying around is a 5 to 10 degree pressure drop. That's most common. Don't see much above, very little above 20. It seems to be in that right now in that 5 to 10 degree or 5 to 10 psi range. And again, this is a good reason to kind of take a closer look at some of the online tools that are available that can help calculate pressure drop and, properly size valves. And I'll touch on that in just a little bit. So again, systems should be selected in conjunction with compatible plumbing fixtures to maximize water savings, such as thermostatic valves at the point of use. So the question sometimes comes up, how does, around conservation, how would a thermostatic valve potentially at a point of use apply to this? And so essentially what a thermostatic valve is doing is, because it is trying to maintain a set point, it's going to only require hot water when needed. So the internal mechanism is going to make an adjustment, and when hot water is only needed to increase the set point, or if there's too much hot water, it's going to increase the cold water. So it's essentially a small little device that's really precisely regulating the amount of hot water that's coming into the valve and to the fixture. So even though it may seem like a little bit, actually, if you're in a large facility where you've got tens or hundreds of valves, it actually becomes quite significant. So talking a little bit more about the interface, and every product is a little bit different. Some products may require a computer hookup. Other ones have buttons. In this particular instance, this is a touch screen interface, and it makes it very simple to access the information. It makes it very, very simple to set the valve up to set the set point. If you're using the pump, if you have a pump tied to the unit, you can easily set up the return temperature that you would like and the parameters of when you want to turn the pump on and off. Setting your high temperature alerts and your low temperature alerts can be done from here. And in most cases, in this one in particular, there's, it's password protected, so you just can't get into the system. In this case, those little blue buttons to the right allows you to actually scroll through data if you want like a quick look to see what's going on in the system. So by hitting the blue buttons, you can see your hot and cold inlet temperatures, your pressures, you can see your mixed outlet, you can see your flow, energy consumption. That you can do without a password. But if you really want to get in and make an adjustment or set or commission, that requires, in most systems, is going to require a passcode to get in. So there is a level of security around these units. So we talked about, again, being able to access data through the building automation system, and now we're starting to see more and more of these units tied into the internet, right? So you're able to, through web apps, through mobile apps, you're able to actually look at data. You're able to look at your facility. You're able to look at various buildings. If you're on a campus, you can look at various fixtures and fittings, and you get an update on operation. Obviously, mixed outlet temperature, texting, messaging, alerts, those type of things. So the systems are actually becoming smarter and smarter. So this is a little bit around protection, zero demand protection. So this again talks about there's 100 with this particular valve, and with a lot of these valves now that you see versus traditional mixing valves. These valves have 100% hot water shutoff. So essentially, the need when you have a low or no demand situation, let's just say you're in a nursing home, or it could be any facility where overnight there's no draw on the system, temperature continues to increase. That typically resulted historically from traditional mixing valves where the shutoffs weren't really tight and there was leakage. The hot water would leak to the cold and actually warm during a zero demand period. The hot water would actually warm the cold water up, and this would be in a closed loop. And actually, over time, theoretically, your hot water could get to the temperature of your boiler. In this type of a system with 100% hot water, the shutoff it eliminates that risk. So you can follow up if you want more information around this, but we can go into some more detail if you'd want to follow up after. But it's a huge benefit. So we have a question for the IntelliStation Junior digital water mixing valve system. Is the recirculation connect always standard, or can we delete this connection if it's not required? So for Junior, the recirculation is on the Junior units, the smaller units. The recirculation is optional. So the valves, if I'm understanding the question correctly, the valves actually do not come with recirculation. It is not it's not standard, so you would have to request this. And if hopefully that answered the question. If not, we can again follow up after the webinar is over. Again, we talked. This actually question came up, so we probably don't need to harp on this slide for too long. But again, just to reiterate, in terms of power loss, the actuator will go to full cold, and there is a manual reset button right about where that red arrow is pointing, where you can go down and manually adjust the valve to a tempered water selection. And then another piece of this is when power is restored, there's non-volatile memory in the controller. So all the settings would come back, right? You wouldn't have to go and reprogram anything. The NVM will do that for you. Now there is one instance where it will not come back, and that's if you happen to be in a sanitization mode. And the sanitization mode is where there's a module within the controller that allows you to superheat water for a predetermined, preset amount of time. So if, for example, you were to lose power when you're running superheated water, it would not return or restore those set points. You'd have to go back in and actually manually do that. That's again a safety feature. Again, most of these units are, or all these units are required to be either NSF compliant, right? Low lead compliant. You'll see most of them are listed to 372 or NF 61, and some of them you can get security enclosures. Primarily, most of these are designed for indoor use. We have seen some requests for outdoor use, particularly in warmer weather climates, where we're, I think many of us that build these and design these units are kind of working towards a solution there. But addressing, again, trying to address performance. Let me just take this one back a little bit. Go to the next slide. So we talked about ASSC 1017. I'll just touch on it one more time. This is the ASSC standard that you'll find point of source digital mixing valves, distribution mixing valves must comply with or listed to. And just one thing around minimum flow. All of us manufacturers state minimum flow. To know where a valve is actually tested by ASSC, it's at 50% of the valve's flow at a 10 psi differential. So when you look at a flow chart or a flow graph and you look at what the flow is at a 10 psi differential, you know that ASSC has tested the valve for control at 50% of that. Now, in many cases, we will state control at lower flows, and that's either because we've manufacturers test at lower flows, so we comply at lower flows, and we'll state that. Or in some cases, we'll talk about you'll go down to a certain flow with a continuously running pump. So, but that's just a little bit of background with ASSC 1017. So when you look at minimum flow, you'll know exactly where ASSC tests it. And then they also have a temperature test, which essentially it increases the hot water temperature roughly 25 degrees within 5 minutes. So every minute they increase the water temperature 5 degrees, and then it must hold within the set point. And the plus or minus 7, we've talked about that quite a bit. When you get into smaller valves, smaller capacity valves, the threshold goes down to plus or minus 5, and for really small valves, I think it's plus or minus 3 or 3.6 now. So, but most of the big valves that we sell, or most of the valves we sell, are larger valves, and they fall into this higher capacity. Again, 1016, to reiterate, is the shower valve or combination shower valve standard, and there's 3 types, like we talked about before. The most common is type P, pressure balancing. Then there's thermostatic, which compensates. So pressure balancing has to compensate for 50% pressure fluctuations, increases and decreases in supply pressure. Thermostatics have to account for, obviously, temperature increases plus, I believe it's 20% pressure changes. And then a combination valve, a type TP valve, actually has to do both. It has to compensate for at least 50% pressure fluctuations and for temperature. So combination valves you tend to find more combination valves in healthcare facilities where temperature control is actually very critical. So ASSC 1070, this is primarily the standard that you will see for valves or at sinks and laboratories and tubs. So these are very, very common. They're all basically type T valves. They're all thermostatic valves. Every manufacturer that does a 1070 valve is a thermostatic valve. Most of them use paraffin actuation. And at 1070, actually the device can be either the final temperature regulation device, or the water can be tempered further downstream. So I would say 1016 and 1070 are the two most common type of valves. So the OSHA guidelines for Legionella, there's also, we talk about ASHRAE 188P, which lists requirements for sanitization mode to disinfect contaminated hot water systems. So this is becoming more and more a big deal. The reporting piece of 188, as well as, again, this kind of sanitization mode, which is something that is much simpler to do with a digital mixing system. Almost all manufacturers have the ability to put their product into a high temperature flush with a preset temperature and a preset runtime, and it can send out alerts. You can send out alerts to the facility. Now, it's critical when you're doing any type of flushing that obviously on the user end, on the point of use end, that there's protocols in place for safety, which is very critical. But clearly, hot water is one of the tools available to address high bacteria content. And we kind of look at Watts. We kind of look at Legionella as kind of a multidiscipline approach, right? So there's different ways to attack it. And if you look at a lot of the cases that are in the news, you'll see that a lot of the remediation involves numerous types of disciplines to address the Legionella. In some cases, you might see a hot water flush, you might see filtration. You might see chlorinization and filtration. You might see copper silver ionization. So, having kind of a multidisciplined approach, depending on, and every situation is different, is really important. So this is a little bit more about ASHRAE, the ASHRAE standard 188P, and you can see the section there. But water temperature shall be maintained at 160 to 170 degrees Fahrenheit. And this is, again, the piece around, having the proper protocols in place by flushing each outlet in the system, right? So very important. Hot water flushing is very effective. It must be repeated, but it's effective, and it needs to be, proctored appropriately. And again, a flush time of 30 minutes shall be attempted. So we've seen this. Actually, I believe we've seen this at the VA for their flushing protocol. They use they recommend, or they use two methods. They use hot water flushing and chlorinization, hyperchlorinization. So when we looked at, we did a poll not too long ago. 32% of engineers specified digital mixing valves to support their goals in energy management. So it was clearly the energy management and temperature control. 25% chose based on the performance capabilities of the temperature control. So those are the two main reasons that we've seen that engineers are migrating towards digital mixing. And there's a lot of other reasons now too, because of, again, the safety and liability concerns. And communications, and tying into the entire systems, being able to talk to. There's all kinds of reasons now as the technology continues to advance, the Internet of Things, as to why digital mixing is making more and more sense. This is a slide. All buildings need to have safe water supplies. Obviously, that's no secret. This is if you look at the graph to the left, you'll see essentially how we've kind of seen the different verticals and where we've seen digital mixing fall and be installed and specified into. Can we do maybe do one last poll question, Greg? I'd be curious to see where our audience is seeing.
Sure.
Yeah.
Yep. Yeah, I'll put up our next poll question right now. So the question, for what types of facilities do you typically specify digital mixing systems? Office, hotel, healthcare, education, all of the above. Give it another 10 seconds. All right. There you go. Should be able to see the results right now. Okay.
So we've got, it looks like healthcare and trying to see what, if all the above. So healthcare and all the above, right? Yeah, so I would say our experience has been healthcare and hotels, clearly, and universities. Those would be obviously the three big ones that we've experienced. But clearly, I think the message here is that digital mixing is appropriate for all facilities. And now with the advent of new kind of smaller capacity valves, you're even seeing it as opposed to like we're putting digital mixing into hospitals. Now we're able to put digital mixing into assisted living and to nursing homes where smaller capacities are more appropriate, where maybe you don't need all the bells and whistles of a larger system. You may not have a building management system to tie into. So some of those things are becoming more important. And let's see here. I'm going to just skip over to, since we only have a couple minutes, I wanted to just touch on product selection. So this is I think just about all manufacturers offer some type of product selection tool, which helps you not only size the product but select specific models. And in some cases, once that product selection is made, there are online platforms available that allow you to actually configure the product in real time. So let's say you put in all your data and based on available pressure drop, which you select or can be calculated, a recommended valve comes out. Actually, maybe 2 or 3 recommended valves come out, are produced, and then from there you can actually go into these tools and you can store those designs, but you can actually configure, do you want to add anything optional? Do you want to add an optional flow package? Do you want to add, let's say, strainers? Do you want to change your return pipe size? You can get into, some more specifics around the design, and you want to add a cabinet for security. And then, again, in real time, it'll provide a product description. It'll provide a submittal drawing. It'll link you to other literature, piping diagrams, those type of things. So, and it'll also produce 2 and 3D files, right? So if you need, Revit files, step files, DWG files, all those files become available. And then once you've done that, once you have this information, you can actually share and collaborate with colleagues, with customers, via email or through a kind of a special collaboration site that's set up. So these tools are available, and they are they're very they're very helpful. And again, getting back to the sizing piece, I think very critical in terms of making sure that you've got the right size valve in your application.
Right, and just to add on to that, Bruce, in the chat window, I added a link to SelectIt, our online configurator, just so you can check it out from there if you'd like.
Okay, great, great. So, yeah, so that concludes really the presentation, and hopefully, you'll be able to, better identify some of the challenges around hot water delivery. You'll have a better understanding of point of source versus point of use and the differences in the type valves and systems. You'll be able to maybe a little bit better articulate digital advances in water mixing recirculation stations that, improve performance, efficiency, and mitigate some of the risks associated with hot water. I have a little bit better understanding of the codes around both point of source and point of use valves. And hopefully all this information will help you to, specify, do a better job with specifying or, using tools that we kind of outlined. And again, all that information is valuable around lead credit, energy efficiency, very important. So hopefully this has been kind of a good overview of that. And certainly if you have additional questions or comments, you can see my name and information is at the bottom right-hand corner of this slide. Feel free to reach out. I'd be happy to get back to you and help you with any questions or that you have.
Yep. Yeah, we did have a few come through in the chat window. Who want to go through those? Bruce, what is the cost comparison for the digital mixing system compared to using a thermostatic mixing valve?
Okay. The quick answer is it depends, but so I think one of the things you're seeing is you've got the larger systems, and those can be could potentially be a multiple of 2-3 times. Some of the I'll just point out some of the mechanical systems, the thermostatic valves, and like for example high lows. Whenever you add piping, manifolding into any valve, whether it's digital or thermostatic, it becomes expensive. But now there's more valves on the market now that are kind of, particularly around smaller type facilities, that are a lower price point. Again, you don't have all the racking, you don't have all the piping, you have fewer sensors, but in some cases they clearly give you advantages over thermostatic mixing in terms of they give you the same type temperature control, they give you the ability to auto balance systems, they give you visibility into past history and data. So there's a lot of pluses, and the premium is can be significantly less. So instead of multiple times the cost, you could be talking 20-50% more. It makes it much more, when you look at kind of the overall value, which I think is really what you've got to do, and the cost savings around setup and installation and callbacks and just accuracy and complaints and guest comment cards and those kind of things, particularly in hotels and even in healthcare facilities, the value is really there.
Great. Next question that came through. If the sanitation mode is standard, would special precautions be required for the network downstream, plumbing fixtures, valves, etc.?
Yeah, so I mean, most facilities, if they're using sanitization, they're going to have a protocol. They're going to have something in place to ensure that everything downstream, first of all, that there's supervision. And in terms of the valves, typically what happens right now is that you have to get the full hot water, because we talked earlier about having limit stops, that limit stops need to be installed and properly set. Those limit stops on all those valves are going to have to be removed, so you can actually get full hot water. Because they're going to try, if you've got a thermostatic valve and you tell the thermostatic valve, I don't want any more than 120 degrees, and if the valve, if you're bringing 160 degrees now, it's going to try and maintain 120. You're going to actually have to remove limit stops. You may even have to take out, in some cases, remove cartridges. We've seen people actually take out the internals. So there is a fair amount of labor involved, but when you look at the cost of Legionella outbreaks, for example, we went through a big one in at 2 VA hospitals not too long ago, where 5 or 6 people had passed away. And so even though these seem like labor intensive, once you have an outbreak and the cost associated with that, it's very minimal compared to the consequences. So just the hotel the Sheraton Hotel in Atlanta just recently, within the last couple months, I mean, they estimate that just in lost revenue, there's estimates as high. There was 1 person died, there was 12 verified cases, and there were 63 probable cases. They just estimate in lost revenue because they closed the hotel down for weeks. They estimated the lost revenue at close to $2 million. And now, obviously, the lawsuits are starting to come, and that's going to even be so. While some of these, costs, when you look at these systems and what they provide, there is value there, right? There is long-term value, so you have to consider that.
Okay, good. Next question here: can the below-counter mixing valve be set to discharge above 120 degrees Fahrenheit to allow for thermal shock treatment?
You can't. Yes, you can do that, but it requires, again, it's going to require some additional work. I believe you might have to remove the cartridge or take out the. You're going to have to remove the adjustment or the stop. There's all under counter valves have some type of mechanical stop to not allow you to go above 120 degrees. So that's going to require an adjustment to do that. And we've seen people do that. I mean, we've actually at the VA we saw this happen for probably close to 1,000 rooms where they had to go in and bypass and clean the valve, and I believe they took the cartridges out too, and sanitized the cartridges separately or the internals separately. So it was quite a big job. Okay.
Is it possible to control dual outlet temperatures, say 120 and 140?
Not with the same unit, not with the same controller, not currently. I don't know. Speaking for ourselves, no, not at this point. You would have to have 2 units.
Okay. Does the digital mixing valve have a contact that can be used to shut down a HWS pump in indirect hot water system?
Let's see. Where is it? Does the digital mixing valve contact used to shut down a pump? Honestly, well, if you can provide your information, I'll have to get back to you on that. I'm not sure. That's the honest answer.
Yep, we'll get back to you, Doug. Another question here: what methods can be used to mitigate Legionella from living in the supplies and local TMVs at public use fixtures where the code requires 110 degrees Fahrenheit or less hot water delivery?
Right. So there are other methods for Legionella mitigation. Now, if you can't do a flush, right? A flush is just for a very specific amount of time. So if you're not allowed to flush, I mean, obviously there's other mitigation options, chlorinization, copper, silver. Obviously, basic things like, there's obviously basic design things like, eliminating, making sure there's no dead legs, continuously running water, right? Making sure that flushing fixtures, right? If a fixture is, and sometimes, that's a manual thing. I know with some laboratory faucets, automatic faucets have a flushing mode that actually, if the valve hasn't been used, it detects that for a certain amount of time and then will run water. But in some cases, we've seen people that actually manually go around and just turn on and run faucets for a designated amount of time just to make sure that water is not stagnating inside the valve or in the pipes.
Would you recommend using digital mixing valve in food processing facilities?
I guess I'd have to know a little bit more about the specifics of what you're trying to control. What are the parameters of control that are required? So that would be something that if you get a hold of us, we would look at it. I know some of our valves have been used in process applications, not many, but we always want to look specifically at what the specific requirements are before we make a final recommendation. So let us know. We'd be happy to look at it.
Okay. Having the DMV at the point of source further from the POU wouldn't increase the Legionella risk?
Well, one of the things that, again, you've got to be able to move the water too. So, continuously, a lot of codes and standards require water to be run continuously. What we're also seeing is that water temperatures seems to be a trend, and it'd be interesting to know. I know that's not one of our polling questions, but we're seeing more and more codes and even engineers, specifying hotter water at the point of source. So we used to see a lot of 120, 125 from the TMV or the digital DMV. Now we're seeing 140. And there was recently, I'm not sure where it's at right now, but there's been some talk in certain states, and the state I live in, Illinois, about running, and there's a lot of debate going on around this, I think, right now, but running hot water from the DMV at 160. So clearly these issues of Legionella are requiring hotter and hotter temperatures, and the hotter you run it at the point of source, obviously, the impact throughout the loop is going to be more effective. But that's why, again, you've got to make sure, ideally, that there's no dead legs or those are minimized, and that you're recirculating flow and that valves are being opened up. And but I think when you look at a system, you've got to look at from one end to the other, and it's important in that whole kind of mitigation. You've got to consider the whole loop.
Okay, great. Another question here. What do you see next for digital mixing?
What do I see next for digital mixing? So I think clearly we're seeing more around the Internet of Things is making the possibilities tremendous in terms of value that can be provided to our customers and to the industry. So that's kind of where we see things going. Providing greater visibility to systems, and being able to provide alerting and being able to look at for example, using the example I used before of a college campus or a large hospital, right, where you may have multiple buildings, you may have multiple digital mixers, you may have a number of things in that whole loop, but being able to have quick visibility to know that your system is performing correctly, that there's that everything's online, that there's no issues, and if there is an alert, that you're getting those alerts and your staff are getting those alerts quickly and are being addressed quickly. So, and then, you know, the whole data analytics piece is huge. You know, being able to profile systems based on data. I think that'll be where we can look at particular specific type of buildings. You know, hospital, 300 beds, and say, okay, you know, having information available to our customers to say, look, this is based on, you know, some of the information that we've collected. These are, you know, some of the things that we can help you with, or that, you know, that might be data that might be helpful to you. So anyways, IoT.
Looks like there's a follow-up to a previous question. So this unit will handle both high flow and low flow conditions, correct?
Correct. But again, look at, you know, make sure you look at the specification sheets just so you can see. Obviously, again, it gets back to sizing. We have very, you know, and most manufacturers have kind of an array, you know, a fairly broad line of, you know, valve capacities. So you want to most closely match, you know, the right valve, and making sure that, you know, the smaller you can go and still cover your top end is going to be of great benefit for you at the low end.
All right, our final question here. What is the most effective way to address Legionella?
Well, I think, you know, again, we actually have somebody in the organization, Janice Summey, that focuses solely on this. And I think I've heard Janice say, you know, if you get like, you know, 10 infection control specialists from your hospital into a room, they'll come up with 100 answers. So again, I don't think we look at one way being the best way. We look at it as a multidisciplinary approach, and that's very specific to, you know, a facility and a particular type incident. So it's something that, you know, we wish we could say one way. You know, some people prefer different types, but again, typically what we see is when you see a remediation, it usually involves, and you can go online and you can read about some of them. It involves 2, maybe 3 different approaches to the system. So.
Okay, great. Thank you, Bruce. And everyone who joined us today, I know we went a little over here, but I just want to get all those questions in, so I appreciate you guys sticking around. Just to let you know, a recording of this presentation and your CEU credit will be emailed to you. If you have any other logistical type questions, you could direct them at me, gregory.jackman@wattswater.com. For any technical, more topic-related questions, please reach out to Bruce at bruce.fathers@wattswater.com. And just so you know, also once this WebEx ends, it'll bring you to a page where you can choose to sign up for our next webinar on September 26th on ultra hygienic drainage solutions. I can send you a link in the chat box right here as well. You can also visit our digital mixing valves page. You can take our CEU course, Smarter, Safer, Hot Water Digital Thermostatic Mixing Stations, or you can check out our online configurator selected that Bruce was talking about. Or you can visit our on-demand webinars page, where you can watch all the recordings of our past webinars in this series and take a quiz right after it to earn more ASPE CEU credits. So thank you, everyone, again, and enjoy the rest of your week.
Thank you.